Test 1, 2. I'm using the fluffy mic today because it's windy. Not where you get chilly. It's like a verb of, the earth. That's what it is. It's windy. I'm not talking about chilly. Okay, anyway, I am Ross, KG4NWE. I wanted to talk a little bit today about powering your HF radio. Okay, so a lot of times what we do when we go out in the field, field day or MCOM, emergency situations, or when we set up, just portable field stations for the afternoon, a lot of times what we'll use, if we can't use commercial power, if we can't plug into a power supply or plug it into the wall, we'll use a lead acid battery. Most of the time when we get lead acid batteries, me anyway, I have repurposed lead acid batteries. This is an 18 amp hour, 12 volt sealed lead acid battery. It looks a lot like something you'd get out of a battery jump box, because that's exactly what it is. It came out of a battery jump box. And it'll run my HF rig and my 2 meter, my 2 meter 440 mobile. I have a FT891 and a TMV71A. It'll run those rigs, a good long while, pretty much all day. Listening and then on and off, transmitting 100 watts or whatever. And this one is a 12 volt 7.5 amp hour. This one came from this one I did actually buy new. It was $11 at the Blue Label Superstore. This is for a game camera system, but after hunting season they go on clearance. So I got like 6 or 12 of them then, and I've been given some here, and I've picked up some out of the trash there, and lead acid batteries are everywhere and we can use them as amateur radio operators. And if you don't know what an amateur radio operator is, or if you don't know what an HF radio is, for those of you who might be watching, find a guy or gal with more than 2 antennas on their car. More than 3, let's be safe. Find someone with more than 3 antennas on their car and ask them, what is this guy on the internet talking about? Okay? They'll explain it to you. Anyways, the problem with lead acid batteries is they're 12.7 volts fully charged. And that's okay, but I've never been able to get full 100 watts, never been able to get full power out of my HF radio with a lead acid battery, and that's because they're 12.7 volts. Or at least that's what I believe. And they charge up, you charge them at 13.8 or 14 and a half or something like that. It's usually, this one is actually written on it, but anyway, and they're heavy. This guy, this weighs 11 pounds, and this guy weighs 5 pounds, 5.5 pounds for this 7.5 for 20 hour. I hate the way they do this stuff, but anyway, 7.5 amp hour 12 volt battery is 6 pounds, and this one's 11 pounds, and that's heavy. So my solution is to use lithium iron phosphate. You've probably seen 18650 batteries, lithium ion. They are like what you'd put in your vaporizer, flashlights, a lot of other things use these types of batteries. And these are 3.7 volts, and they're great. You could put 4 in series and you'll have more than you need. You could put 3 in series and you'll have not quite enough. Okay, you could do the math. But the problem with those is you can't get exactly the range that you need from fully charged to discharged, whether you have 3 or you have 4. These are 3.2 volts each. So your range there, if you have 4 in series, you will have between-ish You know, you could charge them at 14.8, I think, 14.8, and then they go down to about 12-ish, no less than 12-ish volts. Absolutely no less than 12-ish volts. 12.2 or so. I would never get below that, because these batteries will be damaged if you go over or under the voltages, charge and discharge voltages. This is a prototype. It's not a prototype, it's an actual thing, but I kind of copied this design from Survival Tech Nord. If you don't know him, Google on the YouTubes, on the interwebs, and find Survival Tech Nord, and he builds one of these, and I like it. I really do like it. It's a 15 amp hour, 7.5 amp hour, 18 amp hour, 15 amp hour, 4. This is 4152 cells. These are 3.2 volts nominal, and they give you about 14.8 down to 13-ish volts. And I can get full power out of my radio for 6 hours or so running FT8. You know, if you're not 100% duty cycle or 50% duty cycle like FT8 is, if you're just making contacts and you're scanning around looking for QSOs, you know, field day type, you can get 5 hours out of this thing easy. And then if you're out on like vacation or camping or doing some other things, you can get this thing to last all day. This depends on how much you're going to transmit and how much power you're going to use, but it will do 100 watts out of my HF FT891. There's no problem at all. No problem at all. Which is actually pretty cool if you've ever used lead acid batteries and came to find out that you're not getting but 70 watts output out of that radio. Anyways, so this is cool. This is cool. I'm gonna find something to put it in, yada yada yada, and this is the. I'm actually gonna take this one apart, and I'm going to build a newer one. I got on sale. These are used Headway 38120 cells. These are 8 amp hours, but they are high C. They're high power, and these guys will actually do 200 amps. These guys will actually do 200 amps output out of each one of them. And I have 8 of them. So I'm going to have 4 in series, 2 in parallel. So it'll be a 4S2P battery pack. It's for my HF radio. To connect them together, I'm going to use these guys. It's a 3D printed, printed on a 3D printer. It took 13 and a half, almost 14 hours to print 2 of these. They're 100%, they're solid. PTFE plastic. That's a really cool thing. So I'm going to use those, and these babies fit right in there just ever so beautifully. They fit in there perfect. I'm going to put those in a repurposed case. This is a case I had a couple of battery packs, a couple of these backup battery packs, and my hotspots in here, and the Wi-Fi, and all the cool stuff and all the things was in here. But this is going to be repurposed. I had antennas in it on the top of it and stuff. It was kind of cool, kind of silly. You'd have to be into that kind of thing. But anyways, I'm going to put these fit in here perfectly. The batteries fit in here perfectly. So we're going to put them in there. I bought these bars here. I purchased those, they're 37 cents a piece or something like that, but I didn't want to wait. So I have to finish these before we can finish the video, but I started making these. These are copper pipe, smashed copper pipe. So, and I'm gonna round the edges with the grinder, and I'm gonna drill the holes in them so that they'll fit ever so beautifully right there, okay? I'm gonna screw them down, and the mailman is bringing me a pack, multi Anderson power poles. That's going to be cool. So we're going to have those. We're going to use those for the solar charge controller and for the radio. On this, you'll notice this has got a board on it, a circuit board. This is a battery management system. What it does, and it's not needed, so to speak. I'll tell you why I think it's not needed. But what it does is, when you're charging these batteries, you don't really want any one cell to go above 3.6, 3.65, or you really don't want it to get too far above that, because it will damage it and it will decrease the life of these batteries. On the other side, you don't ever want it to go below 2 volts per cell, because it will not ever charge again. Which, if you think about it, kind of ruins it. So this guy is designed so that while you're charging it, it will stop charging of the individual cells so that they won't charge anymore, and let the other cells come up to that voltage so that they're all the same voltage. And likewise, if one cell happens to be off a little bit, when it gets to 2.2 to 2.5 volts, it'll cut everything off so that that cell won't go below the 2 voltage mark, and it won't damage that cell. It also has a equalizing function, which basically when it charges up to 3.6 volts, this particular one will bleed off or adjust the voltages between the batteries so that they're all 3.6 volts. Okay, and that is what that is. So I'm going to use that board over here. I have another one on order, but it's not here yet. Oh, and the reason you don't really need this, if you bottom balance these cells properly, which means if you take, before you put this thing together, if you take these cells individually and you use them down to about 3.6 volts, so they're all exactly 3.6 volts, then when you put them in series, or you could actually get them within a 0.1 or 0.2 volts of each other and hook them up in parallel, and they will equalize themselves. If you do that at 3.7-ish volts, they will equalize themselves and everything will be good. But the main idea is to have them all exactly the same voltage at the bottom of the cycle. So at dead, they need to be the same exact voltage. So when they rise, they might not all be the same voltage, but if one's at 4 volts and one's at 3.9 volts, as they charge, and then they discharge, and then they charge, and then they discharge, and then they charge, and then they discharge, this low in here won't go below 2 volts. So that's the idea there. And as they don't really get off that much. So, I mean, if you're using them in like a car or something, then maybe, yeah, but for the HF rig, we're never going to be using more than 18 amps. Really. I mean, yeah, it's 20 amps, but it really, I've never seen it go above 16 or so amps. So, with that said, I'm waiting on some parts. The mailman's coming with my Anderson power poles and my ring connectors. We're using this 6-gauge wire here, and the charge controller and stuff's going to be hooked up with this 12-gauge, or is that, yeah, 12-gauge wire. And I'm going to solder some things, solder the ring connectors on with the butane. There's the butane soldering iron, which is awesome. I don't need power for that. Got a couple of meters here, my tape measure, so I can make accurate measurements. And this thing right here weighs about the same as all of these together. Okay, so we're looking at, between this and this is half the weight of this. Okay, this is 16 amp hours, or it's going to be, and this is 18 amp hours. Okay, These weigh about the same. These weigh about the same right here. And with the 4152s, 15 amp hours, this is about half the weight of this. So that is the basic. I mean, I can put this in my backpack with my radio and not be like, oh my God. You know what I mean? I'm not like humping a couple of bricks out into the field. So I have to have 14 of these. So I need to make a couple more. And when the mailman gets here, I'll come back out and we will put all this stuff together. And y'all don't go anywhere. Of course, it's only gonna be like a split second and I'll be right back. Hi you guys. Okay, I wanted to show you real quick what I was doing to make these guys here. I've old copper pipe, and I will take this over on the sidewalk, or I use a metal vise and I just beat it flat, and then I'll take it over to the grinder and grind the edges, and then I will mark and drill the 2 holes to match the screws. Okay? Cool beans. 1 second there. All right, so test 1 2, test 1 2. Can you hear me? Over. Okay, so I got it marked. Not marked. I'm going to mark it. I got a mess. This is why I work outside, because if I have like a desk or something that I work at, it really gets messed up. This way everything gets picked up. So the measurement that I want to use in between the cells is 2.6. Let's see, 6.2 millimeters. Okay. 6.2 millimeters. So this is as simple as taking my little pen, 6.2 millimeters. I hope you guys can see this because it's really sunshiny and I can't see the screen on the phone. So pretty much there you go. I know that I could use one to go by and just cut them all, after that one, use that one to mark them and all like that, but it's okay. There's more than one way to build a battery, of course. This is just the way that I've come up with. I like to do things the easy way, and I catch myself all the time doing things the hard way. Anyways, this is what I'm doing. And then I'm taking them over to the grinder and grind them up, make them look pretty. And probably drill the holes first. That way I can grind around the holes. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 more. 13 and 14. The reason it's so shiny is because the grinder we have has a wire wheel on it, which is awesome. All right, check that out. So copper pipe is not cheap. I'm not gonna say that it is, but that particular piece of copper pipe was free. So all in all, said and done, they're all about the same length. These are gonna cost me nothing but time. Here we go. I'm gonna take my permanent, I'm gonna take a pretty one that's not all messed up, because I actually will use it as a template plate. You're gonna give it nice and evened up, and bus bars are going to help it stay put also. Oh, that's about right. So we'll put a hole here, put a hole here, right about there, right about there. That should be close. What do you think? Maybe? You know, I should probably put this together. Maybe that'll help it stay proper. Proper. Okay. Hey, what's up? Y'all in there? Okay, cool. So I got the soldering iron out. What I'm gonna do is I'm going to remove this 18 gauge wire here. We're gonna remove it and we're gonna replace it with, hopefully, it's a little windy, so that's not helping at all. But we're gonna replace it with a 12 gauge wire, okay? And then all that's really left to do, because since this is already pretty much made, this thing's not getting very hot here. Because it's pretty much already made, ow, all that will be left to do is to put the 4S wires on the battery and put everything in the box. Now, this isn't working so great. The number one, this one goes to battery plus. Like that. The next one goes to here. Okay. The next one. Test 1, 2. Test 1, 2. Can you hear me now? Over, over. Cool. Okay, well, the sun went from over there all the way to there. And I'm done, finally. Okay, so, yeah, a couple things. I had to go do some other things and some stuff, and some stuff comes up. Stuff comes up. So I had other things to do, but there it is. It's all done. For the most part. The only thing left to do is find a box because it will not fit in this one, okay? So it won't fit in that box. It would fit in the box, but then when you add a little space for the bus bars, and then space for the screws, and then space for the connectors. Don't fit in the box anymore because it was so perfect. But you got to unscrew the screws, and then there's the space, and then it didn't fit. It doesn't fit in the box. But it's there, and it's done. Everything's nice and snug. They got negative, positive right there. And then you plug in over here for the charge controller, for the solar charge controller. And we're done. We're done. We're done. It's just got a straight Yaesu, HF Yaesu plug on it. Plug straight into the 891 or the FT900 or I think 857 and some other stuff. So later on, what I want to do is I want to put the Anderson power poles, which have not shown up yet. I want to put them where I have these end connectors or butt end connectors or whatever you want to call them, connectors. I want to make this about that long and put Anderson connectors right there. And then I can put Anderson connectors on all the radios and anything else, and then boom, done. Okay, so that's it. It's 8 amp hours. Here, get down here. Well, you can't see. These wires are all curly. 13.33. Check all the cells while we're here. We will go ahead and check all the cells to see are they the same. 3.33. 3.33. 3.33. 3.33. 333. 333, 333, 3.33 for a total of 333. 666, that's not good. 999 and 13.32. Okay, so it's done. With this 16 amp hour battery, it is the same, technically the same capacity as this. It's 18 amp hour, this is 16 amp hours, but I just know deep down in the bottom of my heart that this will last so much longer than that, and it charges faster. I don't know, a lot of advantages. So there it is. I'm gonna put a couple of standoffs here, so that sits just like that, and then the box, find the box that it fits in nice and snug, and then I will put the these wires will terminate to a plug here, and then, you know, all the stuff. Well, we can't do that yet because that box is too small. So with that, that's kind of what happened today. I did some other stuff too, and I got a cool idea to use this for. I mean, it's like 2 pounds or 3 pounds or whatever. So super lightweight. It's cool stuff. So anyway, I'm KG4 and WE. It's been a very long, boring video. I understand. But yeah, something to play with. Peace, love you.